Hello, hi Tanam, how are you? 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 Hello, hello. Hello, hi Tanam, how are you? Hello, hello, hello. Hello, hello, hello. 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 Hi Tanam, how are you? On Skype, I'm not able to hear you. Let me again call you. Actually, I was not able to hear you on this. Hello, hi Tanam, how are you? Hello, hi Tanam, how are you? Hello, hi Tanam, how are you? Hello, 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 hello. Hello. Hello, hello. Yes, now I'm able to hear you actually. I think headphones were not connected properly. Please wait. Uh, Hello.
Hello?
Yeah, now it's fine. Yeah.
Okay, right.
All right, great then.
Shall we start?
Yeah. So we do not solve for limit here where x tends to minus infinity.
Where what, sorry?
We need to solve on limit basically where x tends to minus infinity.
Okay, sure. Yeah, let's do it.
Oh, yeah. There we are now limit x tends to minus infinity. So 2x to the power 5 minus 6x to the power 4 plus 1 whole divided by 3x square plus x minus 7. So we can take common here, divide both sides, numerator and denominator, by x square. You will get this. Then apply x tends to minus infinity. You get the answer as minus infinity. Have you got the question? See what we have done here. Let me again do this. Limit x tends to minus infinity to x to the power 5 minus 6x to the power 4 plus 1 whole divided by 3x square plus x minus 7.
Yeah.
So now we can just divide numerator and denominator by x square. Here we have. So it will be limit x tends to minus infinity.
Yeah.
So here we have now x square common. So it would be 2x cube minus 6x square and plus x to the power minus 2 whole divided by x square common. So 3 plus x to the power minus 1 minus 7. Here we have x to the power minus 2.
Yeah.
So this coming out to be 0 here, this coming out to be 0 here, 0 here. Cube here we have minus 6 into minus infinity square. That is coming out to be minus infinity is the answer.
Yeah. Yeah. So we can put it.
Yeah, definition now here we have. Oh, this you have already done, I think. Or not done. No. This is not done actually. See, it says that we say that fx approaches infinity as x approaches c. And right here we have a limit x tends to c f of x is equal to infinity. If for every positive real number b there exists a corresponding delta greater than 0, such that for all x 0 less than modulus x minus c less than delta. So for this domain we get the range as fx greater than b. Fx greater than b. Or we say that fx approaches minus infinity as x approaches c. See, in this graph, fx is approaching minus infinity below, fx approaching minus infinity as x approaches c.
Yeah.
So 0 less than, here we have modulus x minus c less than delta. So for this it corresponds to fx less than minus b. So if we say if we are in this range,
Yeah.
in this range we look at basically, so between this range or this range or this range, fx will be always less than minus b. You can see here in this range, fx is less than minus b.
Okay.
Fx less than minus b, here we have for this 0 less than modulus x minus c less than delta.
Yeah.
Example 14 now. To prove that limit x tend to 0, 1 by x square equal to infinity.
Yeah.
Given is b greater than 0. We want to find out delta greater than 0 such that 0 less than modulus x minus 0 less than delta implies 1 by x square greater than b. So let me first go through this again. Fx is greater than b. Here we have for 0 less than modulus x minus c less than delta.
Yeah.
So this we use here in this. It implies now 1 by x square greater than b. So 1 by x square greater than b if and only if x square less than 1 by b.
Okay.
So from here we have now modulus x is less than 1 by root b. We take now here square root both sides.
Right. Yeah. Right. Yeah. And then modulus.
We take now square root both sides. Here we have. So modulus x is less than 1 by root b. So from here we have delta equal to 1 by root b.
Or minus 1 by root.
Delta equals 1 by root b we can take here.
Yeah.
So from here we have modulus x less than delta. It implies 1 by x square is greater than, now b is, from here delta is equal to 1 by root b. So square both sides, delta square is equal to 1 by b square, or b square is 1 by delta square.
Wait. Okay. This part is okay.
Yes.
This part is okay. Now here.
1 by x square greater than we have 1 by delta square.
So 1 by x square is greater than 1 by delta.
Delta square is greater than equal to b. Here we have
Because you are putting what? Delta is equal to 1 by b square. 1 by root b.
delta is 1 by root b. Yeah, delta square is 1 by b square, or b square is 1 by delta square.
Okay. Fine.
So here we now limit x tend to 0, 1 by x square, that will become equal to infinity. Limit x tend to 0, 1 by x square is equal to infinity. Here we have. Next we have now the vertical asymptotes. So horizontal one we have already done. Now let us discuss the vertical asymptotes. Here we have now vertical asymptotes. Here we have. So now here we have for the vertical asymptotes as x tend to 0 plus. As x tend to 0 plus, the function leads to infinity, and as x tend to 0 minus, the function leads to minus infinity. As x tend to 0 plus, the function leads to infinity, or x tends to 0 minus, the function leads to minus infinity. Now we see the line x equal to 0 here. This line is the vertical asymptote for the given function. The definition is given as a line x is equal to a is the vertical asymptote of the graph of function y equal to fx if either limit x tend to a plus fx equals plus minus infinity, limit x tend to a minus fx equals again plus minus infinity. So as x approaches a plus or a minus, if the function goes to infinity, we can say there is a vertical asymptote. Now you can write here the definition of horizontal asymptote. So same here for the in the limit terms of limits. Here we have Write the equation for horizontal asymptotes.
So the definition was well that if limit of f of x is equal to infinity, right?
Limit of you have to write this here, limit of for horizontal asymptote.
Yeah, right, but that was it.
Mm-hmm.
That was the body. Horizontal one was f of x equal to b. Yeah, right.
Here we have now limit x tends to infinity. Yeah, perfect. Yes, please go through this example now here and find out what is the asymptote of the curve here we have. Learn the method now.
Yeah. Hello.
Yeah. So have you got a solution here?
Have you got a solution here?
Okay, take your time.
you're interested in the behavior as x tends to infinity because that's where you get the horizontal asymptote, right?
Yes, yes.
Get the how do you get? Why do you have to make the denominator 0? How does that help you?
Denominator has 0. No. Let me tell you how to find the horizontal vertical asymptote here. Very simple method, okay?
Yeah.
Let me give you the concept here. So here we have y equal to x plus 3 by x by 2. My x plus 2 here we have.
Yeah.
So now let's find out here first of all the horizontal asymptote. So limit x tends to infinity, for example, x plus 3 by x plus 2. So limit x tends to infinity, here we have x common 1 plus 3 by x, okay, my x common, so 1 plus 2 by x.
Yeah.
This cancels out, so it is 0, so 1 by 1 is 1. So we get here y equal to 1 is the horizontal asymptote. Getting it?
Yeah.
Now how to find the vertical asymptote? The method is to find out vertical asymptote. So we have now y will be at vertical asymptote, you have y is infinity. So we can put y as infinity, right? That is 1 by 0 is equal to, that's the method only, 1 by 0 is equal to x plus 3 by x plus 2.
Okay.
So from here we get x plus 2 is equal to 0, cross multiplication, or x is equal to minus 2.
Right. That is how you get the vertical.
Yes, here we have x equal to minus 2.
Okay, like that.
Yeah.
Getting the answer equal to 1 by 0.
Yeah, for finding out the vertical asymptote, put y as 1 by 0. For finding out the horizontal asymptote, put the limit x tends to infinity.
Mm.
That's it. You will get the asymptotes. And now, how to draw the graph here? So for the graph, you have the asymptote horizontal one, y equal to 1, vertical one, x equal to minus 2. Now let's draw the graph here. Horizontal here we have y equal to 1.
Yeah. So it will never go past that.
Vertical here we have x equal to minus 2.
Yeah. Yeah. So now how do you draw the graph?
The graph is coming out to be like this. Now we have to just look at some points here. It is x plus 3 by x plus 2, right?
Yeah.
What I can do, let's take here x as 0, for example, okay?
Yeah.
When I put here x as 0, just take one or 2 point. 0 plus 3 by 0 plus 2, that is 3 by 2, 1.5.
Yeah. But that is not part.
No, that is there, 1.5 here we have, 1.5. So that means that means the graph is like this one and this one. Are you getting it? And here it will be just a mirror.
Okay. So how? Okay. You substitute some values and then you see.
Yeah, absolutely.
Okay.
Okay.
Yeah.
Example 16 here we have now. Fx equals minus 8 by x square minus 4.
Yeah.
So here we have complete solution for that. Now please go by same method and just find out the asymptotes and draw the graph.
Yeah.
Yeah.
Then or graph of 8 by x square by. So I'll just push it to the side. One second.
Yeah.
Okay, so you say x tends to infinity,
Mm-hmm.
right? So then minus 8 by x. So this is 8 by infinity is 0, 0 divided by
Mm-hmm.
infinity
Okay.
and 0 only. Because this
Okay.
is 0 minus 0 is 1
Yeah.
and this so infinity.
So draw the graph now.
Yeah, so the limit horizontal limit is 0,
Mm-hmm.
vertical limit you said 1 divided by 0
Yes.
is equal to minus 8 by x square.
Okay.
And now so x square
Mm-hmm.
minus is equal to 0, x is equal to 2,
Yes.
right?
Okay. Yes. Yes. Yes.
So plus minus, which one do you take? You take both.
Yes. If the value of x is coming, yeah, we take both. Yes. Why not? Let me just confirm. Let me confirm here with the given graph. Where's the given graph? This
Yeah,
one.
there.
Yeah. Continue.
And now, well, now we have these limits. And now to find out how it works, how that graph looks like, only that's a bit confusing.
Yeah.
So,
So I think you are clear with this now.
yeah, I'm clear, but it's one question.
Mm-hmm.
No. Wait. Okay, so now we have a horizontal limit at 0,
Mm-hmm.
but we don't need to draw it. This is the axis.
Yeah.
Now we have 2 and minus 2.
Okay.
Right?
Mm-hmm.
How do you now just have to substitute values, is it? And now how you get the answer, how you can draw it is just by substituting values, is it?
See, for this one we have yes. What is the graph? I mean, function here we have fx equals minus 8 by x square minus 4, right?
Yeah.
So minus 8 by here we have x square minus 4. So let's take next equal to 0.
Okay. So then that will be just 2.
So x equals 2 here we have now.
Yeah.
And what about the horizontal asymptote you got?
0.
0.
Yeah.
Okay. And what about this value? Minus 2, right? This plus 2.
Yeah, yeah, 2 and minus 2.
Okay. Now take x equal to minus 4. Minus 2 by 3 here we have. So, okay. No. This is going like this here we have, and this here we have. And then start like this, and this. It is here plus infinity. So minus infinity here we have this one. This is the graph here we have now.
Yeah, so you did that by just substituting values, is it?
Yes, yes.
Okay, so you do that for say 10 values and then draw it.
Yeah. Yeah, if you're confused, you can draw some more values and then you can just make the graph. The graph is always like this for the asymptotes. Infinity here,
Yeah,
plus
I know,
infinity,
but
yeah.
technically the graph could also be like this, right? The graph could also be like this.
But it will not pass to that point. It could be like this, yeah, I got your point. Yeah, yeah.
That to be there. So that's why we need to know.
Yeah, you return the points basically. This graph will not satisfy this. This graph will satisfy this.
Yeah.
The curves here we have now y equal to sec x equal to 1 by cos x, or y equal to tan x equal to sin x by cos x here we have. These two curves both have the vertical asymptotes at odd integral multiples of pi by 2, where cos x is equal to 0. So this is y equal to sec x here we have, y equal to tan x. Both the graph you must know, okay? And now can you draw the graph of y is equal to cos x here, just below this, and draw the graph of, yeah, first draw this graph now, y equal to cos x.
Hello?
Yes. Hello, yes.
Yeah. For cosec, isn't it just the other way? It's like literally just this, right? So
Yes, absolutely. That's right. Perfect.
that
That will be actually, yeah,
something like this.
perfect, perfect. Yeah.
But at the same points at one only.
See,
If it's at
the idea is actually for the inverse function here, not inverse, reciprocal function here we have. The idea is if this here we have sin x,
I mean, that what I've drawn is literally just mirroring it on the x-axis.
mm-hmm.
But mirroring on the x-axis, that is just minus of that, right? That is minus cosec.
So here we are now sin x basically okay. Reciprocal is just make it above it. So put the line like this one, then this one, then this one, then this one.
Yeah. Yes.
So here we have now it's coming out to be like this. So this we have here now cosec x.
Yeah, that's cosec.
This graph, yeah, cosec x.
Yeah, that's cosec. Now minus cosec is what?
Which one?
Minus of that would just
Minus of that would just the positive x will become negative. See, minus of cosec x will become like this reflection
in the x-axis or in the y-axis?
in the y-axis.
Y-axis.
Yeah, here we have the minus one like this. This will be minus cosec x. No. I am wrong this time because it will be reflection along x-axis. Here we have it will be this, then this. This we have here now minus cosec x. Next you have an example I'm writing here.
Yeah.
Example 18 here we have now. And fx is 3x to the power 4 minus 2x cube plus 3x square minus 5x plus 6. And gx is equal to 3x to the power 4. Show that although f and g are quite different for numerically small values of x, they are virtually identical for modulus of x, very large, in the sense that the ratios approach 1 as x tends to infinity or x tends to minus infinity.
Yeah.
So when our limit x tends to plus minus infinity, fx by gx. This we have fx here, this we have gx here.
Yeah.
So 1 minus 2 by 3x plus 1 by x square minus 5 by 3x cube plus 2 by x to the power 4. Limit x tends to plus minus infinity. When you put x as infinity here, it all becomes 0 and the answer is 1. So for this graph here we have, the given graph here we have, this is a very steep line. Very steep line here we have from here to here like this. Now next here we have, there's a homework for you, limit 1, okay?
Yeah.
Derivatives now. So tangents and derivative to at a point. Tangents and derivative at a point.
Yeah.
Tangents and derivative at a point here we have. So at this point, it is y equal to fx. Now let's at this point draw tangent here. So this point is x naught plus h. This point is x naught here we have. So limit s tend to 0 f of x naught plus h minus f of x naught whole divided by h. This will give the dy by dx.
Yeah. Just could you give me 2 minutes? I'll be back.
Let me again repeat that, okay?
Yeah. I'll just give me 2 minutes.
Yeah. Sure. Hello.
Yeah, hi.
Yeah, hi. So here we are now finding a tangent to the graph function here we have.
Yeah.
So let's discuss this now. Here we are now, it's coming out to be, this is coming out to be y equal to fx, right? A tangent here at this point is x naught plus h, and x naught here we have, so x naught f of x naught plus h minus we have f of x naught by h here we have, so limit h tends to 0. So this how we can define here dy by dx. dy dx is equal to limit h tend to 0 f of x naught plus h minus f of x naught whole divided by h.
Yeah, you're doing this, but you're saying h is becoming 0. You're replacing h with 0. How does that work? How
I
do
mean,
you do
see,
that?
let me just do this here. Let's suppose here we have basically, for example, if we say delta y by delta x, for example, we're not taking here instantaneous. We are not taking, this is instantaneous and this one is average.
Hmm.
In the average, we take the final point, that is f of x naught plus h minus f of x naught whole divided by x naught plus h minus x naught. Do you understand this? That's how I find out the slope of a line.
Yeah, slope of the second.
Yeah, absolutely. Slope of second. Yeah, absolutely right. This one gives slope of second.
Yeah, but the slope of the tangent should be just the derivative, right? Why are they trying to limit of something?
No. We have to make it instantaneous, na. Derivative means instantaneous only. For example, we say acceleration is dv by dx. I'm sorry, dv by dt. That is instantaneous. Or we say velocity is dx by dt. That is again we have instantaneous.
Okay. So the limit f of x plus h minus f of x divided by h,
Mm-hmm.
that is the tangent gradient.
Yeah, tangent gradient we have. So here we are now delta y by delta x is given as is equal to f of x naught plus h
Yeah, one second. A little bit complicated.
whole divided by h here we have. Hello.
Hello, yeah.
Yeah, so now to make it now instantaneous, we put here limit as tend to 0. Here we have delta by delta x is equal to f of x naught plus h minus f of x naught whole divided by h.
Yeah, see, now that is the instantaneous gradient,
Yeah,
right? Um, yeah, and how do you do that? How do you possibly, how can you evaluate this?
I mean this we have from here we find out the slope of tangent. From
Yeah,
here we
the
find out
slope-
slope of tangent.
Correct, the slope of the tangent, I would just, would you not rather just do y2 minus y1 divided by x2 minus x1?
That's what we are doing. That's what we are doing only. See, delta by delta x is given as, for example, here we have y2 minus y1 by x2 minus x1. If you look at the graph here, we have y2 is equal to f of x naught plus h. This is y2, this is minus y1, this is x2 and x1. Getting it?
Yeah,
So this will be y2 minus y1 by x2 minus x1.
yeah, that is the average.
Yes.
Yeah, but for instantaneous also you can do that same thing, no?
Instantaneous, yeah, we have same thing, but we put the limit as tend to 0.
Huh. But how do you substitute it and how do you do it then? Can you calculate it, please?
Substitute and how do we do it and calculate it? I mean,
Because if h is equal to 0,
mhm.
you can't divide anything by 0, no? If that's the case,
No. I understand your point. We are not saying h equal to 0. We're just saying limit as tend to 0. We are not saying h equal to 0. We say just h is near to 0. H approaches 0. It is not 0.
yeah. So then how would you calculate it?
We will calculate later on. I mean, we understand. But graphically, you understand what is meant by derivative?
Yeah, graphically it's fine. That is okay.
All right. So I'm in next meeting then tomorrow. Then
Yeah, sure. Tomorrow.
tomorrow I mean we can have like Sunday 2 p.m., 3 p.m., 4 p.m.
9:30 is also fine.
Same time tomorrow.
Yeah, sure. But 9:30 I think would be better.
9:30.
Yeah.
Okay. Sure. 9:30 p.m. then. Yeah. Okay. Thank you. Bye bye.
Bye.
Bye.